Welcome everybody. We're talking about hands-on here for hacking sessions. Is there anybody here who doesn't know what a hacking session is? Just check. Oh, good. So this is going to be a how-to. Tyler's going to take us through actually submitting an example of jobs, and we also want to talk about some of the problems that we have. So people copy jobs and they leave metadata in, which affects all sorts of weird, wonderful things in the whole Lava world. So basically, the outline is there is a JSON job control file that will change in the future when we get to the new dispatcher, but that's a ways down the road. There are repos in git.linaro.org for hacking sessions for all sorts of different operating systems, and in those repos are YAML files which contain the code to do the hacking sessions. You don't have to use those ones. You can actually clone them, make modifications to them, do anything you like. We've had people making bespoke ones which, when the device is ready, it pings you on IRC to say, oh, your device is ready for you, so you don't forget that you've got the device, that sort of thing. Because that's another issue we dealt with in the last session, is people forgetting that they've done it, Milos.
I'm only setting the timeout 3 hours max.
No, okay.
So it's not.
You're forgiven. But
not my fault.
some people submit a hacking session, forgotten they've done it, and they've got a 3-4 day timeout, and there's a device just blocked for 3-4 days. We have other ways of solving that, but that was the last session. Anyway, I'm going to hand over to Tyler now.
All right. So I prepared a little demo for you guys. But first, I just kind of want to go over some of the JSON schema that you'd use for hacking sessions. So as we should all know in here, that we have a couple actions here. So this first action I've highlighted here is the deployment action. You describe what you want to put onto the board and things like that. So we can pretty much ignore that piece. Here's the part that actually does the work. It's a Lava test shell script, essentially. That's all it is. There's nothing special about it. It's not integrated into the dispatcher in any way. Obviously, we give the git URL and we tell it what file to run, and we have 2 parameters. So the first parameter is the gateway. Now, I get this question quite often. Why do you guys have a gateway? It's to detect the route, so I can tell you what IP address to connect to, because on machines that have multiple network interfaces that might be connected to different subnets, we need to find the route. We need to find the interface and the IP address associated with that interface that has the default route to the main gateway, so that's how you get SSH in. It's a very important concept to know. Typically, if it's in the lab 10.0.0.1 is what you can use, and you don't have to think about it. But that's the reasoning behind it. When you have multiple interfaces, you have to figure out what your IP address is when you might have multiple. Second parameter, my public key. Now this is a 4096 one, so it's pretty long. But yeah, that's it. So what this is going to do, it's going to bootstrap these images that I've given it here, and it's going to install OpenSSH server, install my key, and essentially just wait for me to connect so that I can have the platform for interactive use. Now, since we're Linaro, we're committed to doing upstream. I'm going to give you a demo. This is the latest binaries from Mustang from mainline that we're going to boot on it. We're going to use the latest Ubuntu file system, 64-bit file system to run the demo. So I've already taken the initiative to submit the job, so we can just have a look here. You can see the job is running. Look at the complete log. Okay, so this is using NFS. So what I've specified here in the definition is a device tree blob, the upstream kernel image. Now, many of you know that work on Mustang that doesn't have bootz in U-boot. So Lava actually wraps a U image for you and creates that with using the text offset for load and execution addresses. So it does all that stuff for you, so you can take a vanilla upstream kernel and just simply boot it on the Mustang. And that's what I've done here. So if we look at the log, we see the kernel boots, and hey, look, the NFS file system mounts, and we get a prompt, and then the scripts start to run right here, which installs OpenSSH, installs your key. And at the very bottom, you get this nice little, I wouldn't really say it's nice, but this is what we've hacked together, right, to give you the information about what happened. So it tells you what key was installed, in case you have any question. It shows that the SSH process will be restarted. It tells you what gateway you used. And so what I can simply do is just do it from Control C here, and I'll pull up on my terminal. Maybe I should show this real quick. You see that all right? So this is the bit that I use to proxy my way through the lab. So make sure that I'm using forwarding agents.
This is very important. A lot of people, I get a lot of prompts on IRC saying that SSH line I've got doesn't work, and
Yeah.
they haven't actually SSH'd into the lab. So that.
So let me just
I wasn't
show
gonna
you the
name names.
example here. So if I hit enter here, it's going to say, I don't know what that host is, right? Well, it's because it's a local IP address.
Yeah.
So what you can do is if you paste it and just type .lava and you run a similar configuration to what I have, it'll take a second since I'm on the Wi-Fi here, but it's going to proxy its way in the lab, and then from the lab, it's going to forward your authentication agent to the device. You'll authenticate with key, and here I am in a prompt. So 319, right? We can. See, we're running on an 8-core ARM64 platform now. This is running over NFS. People are like, I don't want to use NFS because it's slow. Well, we've actually gone through and read the kernel documentation and optimized NFS for all of our platforms, and specifically for the labs network. So let's see. There. Let's install C compiler. So 100 or so megabytes with apt. This is fairly quick process, so it's not like this is something that's slow. So this whole process has taken me less than 4 minutes to bootstrap a APM Mustang with a mainline kernel and whatever root file system that I want, gain a hacking session, and now I have it for however long I've specified the timeout. Now again, we had the session before this where we prefer if people were good citizens, and when they were done with the hacking session, as I'll show you in a moment here, you know, to disconnect it nicely. So let's see. Oops. So GCC is installed, and we can do whatever we want here. We can compile things, we can run tests. It's really up to you. So when I'm done with the session, I can auto-complete this. We put this in your bash path, right? So please use this. You can tab auto-complete. This basically says, I'm done with the session, and tells Lava to go and complete the job and put it back into the pool so other people can use it. So that's all they have to do, and then you can just exit. And if we go back to here, what you see, it's already stopped. Job's done, power's off, that thing's just sitting in the lab powered off now, and it's ready to take on the next job. Is there any questions about that? I know it's kind of quick overview.
I have a stupid question that isn't really about the usage, just because I'm curious.
Mm-hmm.
Are you doing anything clever with the NFS mounts?
What do you mean?
Define clever.
Define clever.
Yeah.
Are you playing with overlays or anything like that?
No, it's basically, we wanted it to be a vanilla developer interface. Like, you tell me, you munge around your rootfs however you'd like it. You install your developer tools, and you simply just give it to Lava. Lava unpacks it and serves it to the device.
Yeah, I was just wondering if there was something you could do where if you mounted like a static and always there root file system,
Mhm.
and then mounted a writable overlay on top of that.
Yeah. So you actually have control of all the boot options. So if you wanted to have, if you had an NFS share, let's say on Hackbox, that has all that stuff, you could simply just override the boot commands. And
I mean, so what you actually do is you create a copy of a distribution,
Mhm.
and so mainly for saving this storage on the server side.
Yeah, I see what you mean though. So, and then we also had another request to be able to have persistent NFS hacking sessions where, like, I should just bootstrap this and install GCC. Well, I don't want to do that every time I run it, right? So that I could type a command, Lava would say, okay, I snapshot that for you, put it away somewhere,
Yeah.
and then next time I run it, I can simply reference that snapshot. Lava pulls it in, and all your development tools are there. We've also talked with some of the virtualization guys, and they seem to like being able to mount another NFS share at the home directory with all of their tools and things like that. So that is something that we've talked
So
about.
persistent NFS shares is something that, I mean, that would be really useful for me, because probably the kind of thing I would use this for, I mean, I tend to have the hardware I need
Yeah.
to test stuff on, but sometimes I don't, and sometimes maybe I want to have, I really want to test this feature, and then I will be building some utility to actually test that feature.
Right.
And then I might want to come back some later point with a new kernel and test the same feature again.
Right.
So that would be really handy. Not
Yeah.
vital, but just handy.
But we need to figure out how the dispatcher deals with that, because and then, you know, the schema, how you reference your snapshot. I mean, it's essentially like now we have to have some sort of publishing thing, so we can publish your root file system somewhere and reference it later, and other dispatchers know to go look there and say, give me the snapshot for this thing here, and it allows you to download it. So it's something that we can definitely look at.
I mean, you want something, maybe rather than a publishing API from Lava, could you not do it as a command from within the image?
Yeah, I mean, that's
So you actually say hack save.
yeah, the problem is that
FS.
you need to then publish that somewhere, because you have, what, 16 dispatchers in the lab, right?
Oh, right. So what
So-
I would suggest is that we make a specific place
Yeah.
that people can save those.
Yeah.
And that's all in the YAML then. Yeah.
Yep.
So, and you just give it. You'd say hack save FS and give it a name and a path
Yeah.
that you want, and it will create create the path to it for you.
So there's a hack for overlays that I haven't been advertising, but since you asked, I'll go ahead and say it. So there's a parameter that's called modules, and it expects a tarball, right? So you put your lib, modules, kernel version, all your module dependencies in there. And Lava says, I'll unpack the NFS rootfs, and I'll just unpack the modules to the root of that, right? Well, it doesn't look for file structure in there. So if you were smart enough to say, well, I need, you know, these little bits here, and you packed it into a modules tarball, it's going to explode it on top of the root of that NFS root. So you could shim in XE network configurations or things like that if you need to, although it's not ideal. I try not to advertise that because people can do all sorts of weird stuff with it, and I don't want to give them that much rope, hoping that they don't hang themselves, but you never know.
But yeah, I think the idea of doing, I've got the FS into a state I wanted for the future, and then whatever we write in the hacking session comes back and says, right, for future reference, your root FS is this one,
Yeah.
and the path.
So we're looking to make it a little bit better by exposing, like, so Lava Dispatcher knows its own IP address. So we wouldn't need you to tell us the gateway, because all that information could actually be given as environment variables to the script. And so we're looking to get rid of that whole gateway thing by doing that. So we could use IP route GAT with that IP address of the dispatcher, and it would figure out what interface is talking, or which IP address is talking on that interface with that IP address. And once we have that, that'll simplify things a bit. And then what we're thinking for the new dispatcher is that we're moving to LDAP. Your keys, your public keys are already in LDAP, right? We're going to hopefully get away from ever needing to have to insert your public key into the JSON file. Essentially, your user will be linked with your SSH keys when you submit a job. It'll figure everything out. It'll pull your keys. Maybe you have multiple keys right now. You can put multiple keys in, but you have to just kind of append them to the end of the string, which isn't all that great. It'll just pull all your keys from LDAP and install them, and so you can use whatever keys you want. Is there any questions about hacking sessions? And I think that's really all I had, is just to show and tell.
You'll be fine.
Good, sure.
Would anything additional be required for that to kind of work?
Would you like a demo? I could show you a demo. But no, it wouldn't. That's the end. So this is my Lava instance here. Let me just see if networking is working on the D01. I'd have to look about the network driver, but see, this is UEFI boot here, doing our all of the fun stuff that we talked about not doing yesterday. But it's essentially to Lava. It's not. It's as long as Lava is integrated to do NFS boot or image deployment, it doesn't matter about the hacking sessions. It's agnostic. It's user space level. Doesn't care about the bootloader. So
Okay, so we fix the problem one end and it'll just work here. as well.
exactly, yeah. That's the idea. So even with an installer testing,
Yeah.
right? Run the installer. When it gets back into the image that it's laid down, you could run a hacking session and get in there and just make sure that things look sane and
Yeah.
things aren't broken. So that's ideally, like some of the Debian testing that we want to do. Provide them that, let them run automated tests, but when there is a problem on hardware they may not have, they can use a hacking session to get that interactive access and run tests on it to actually pretend like the hardware's in front of you without physically being there. Anything else? Okay, we can wrap it up early.
That's good.